Assalamualaikum warahmatullahi wabarakatuh. To our lecturer, Prof. Lukman. Today, I would like to present about the carbon black production. Before I start, I would like to introduce our group member, which is first is my name is Muhammad Nur Fitri bin Mustaza, and there are four of our group member, which is Farah Aina, Nurul Atikah, Nur Syahadah, and Tanjumin. Application of the carbon black. There are many applications that are using carbon black in the respective industry. First, in the rubber industry, they use carbon black to make tire, conveyor belt, flexible tube, and sealing profiles. For the dyeing industry, they are use the carbon black to make printing in India ink, paint and varnish, and UV protection of plastic. Third industry is the electrical industry, where they use carbon black as an electrode, carbon brush, capacitor, capacitive deionization, and batteries. For the agriculture industry, they use the carbon black as a flower soil. And lastly, for many more industry, they are using the carbon black as decor paper, fiber, and mascara. Next, this is the block flow diagram for our carbon black production. First, feedstock is entering the furnace along with the natural gas, which will be used to heat up the furnace, and the preheated air is being used, and the quench water is being sprayed inside the reactor. And after the reactor, it will move to the heat exchanger, where it will exchange the heat to heat up the air coming from outside. Then the carbon black stream will enter the back filter to filter the dust, and then it will go to the hammer mill. After the hammer mill, it will go to the blower, then to into cyclone, then enter into the agitator. After that, the carbon black will be dried.
So we're moving on for the feedstock part for the carbon black. We use acetylene hydrocarbon as the raw material formed in the gas phase. We have to store the raw material around 70 to 120 degrees Celsius. So acetylene gas is pumped from the storage tank will be homogenized by stirring or by cycling to the reactor via an oil preheater. At a certain distance from the feedstock injection, the thermo-oxidative reaction is arrested by injection of water, whereby the carbon black formed and the reactor of gas are cooled. After further cooling in heat exchanger, this process obtains carbon black with higher structure and higher crystallinity by thermally decomposing acetylene gas.
Hi, I'm Jomin. Now I would like to talk about the classification of manufacturing carbon black methods. There are a lot of manufacturing methods shown in this table, but our group has finalized by using the oil furnace manufacturing method to produce carbon black. This is currently the most common method used globally, where the raw material is the aromatic hydrocarbon oil, which involves the incomplete combustion. Okay. Now I would like to talk about the furnace black reactor. In the furnace black reactor, there are four zones, which are the combustion zone, mixing zone, reaction zone, and lastly the quench zone. In the combustion zone, the hot air in will be at the temperature at 800 degrees Celsius, while at the mixing zone, the feedstock will go into the mixing zone at the 70 degrees Celsius to 120 degrees Celsius. After the mixing zone, the reaction of the reactant will be carried out at the temperature which is 100 to 150 degrees Celsius, and at the reaction zone is covered by the heat resistant material which can withstand the which can withstand the high temperature. When the reaction is done, the product will be at a temperature of 700 degrees Celsius to 1000 degrees Celsius and will go to the last zone, which is the quench zone. The quench water will produce at the temperature of 900 degrees Celsius to 1000 degrees Celsius. Okay, now I would like to talk about the process of the furnace black reactor. The feedstock is introduced into the hot gas stream, which is at the combustion zone. After that, it will go to the mixing zone, where the feedstock will vaporize and paralyze to form microscopic carbon particles. After that, it will go to the combustion zone, where the reactant will move along the furnace chamber. And lastly, the product formed from the reaction zone will go to the quench zone, where the water will be sprayed countercurrently with feed flow. The reaction rate of furnace will depend on the water spray. And lastly, at the exit of the furnace, the carbon monoxide, hydrogen gas, and carbon dust will be produced. Okay, that's all for my part. Thank you.
So next, I'm going to proceed with the separation part for carbon black. So the carbon black is separated from the tail gas by means of bag filters. There are two different types of filter system that are in use. First is the repressed bag filters, and second is the pulse jet filter. So for this system, we have chosen to use the pulse jet filtration system. So for this system, this is the picture of how the system works. So first, the carbon black particles, the air enters the chamber from the bottom, the filter inlet, and then the carbon black particles will get filtered by the filter here, and then which allows the clean air to pass through the filter, and it exits from here. And then for the clean air that passes through the filter, the air gets reused, and then for the carbon black particles, the cleaning air passes through from this inlet, and then it goes into the filter, which will make the carbon to be detached from the filter here. So the carbon black gets filtered and cleaned from the bags, and after that it falls here to the solids discharged, and it gets conveyed away from the filter from the separation system to the next unit operation. So next is the conveying. For conveying, usually they use pneumatic conveying because it is powder. It is in powder form, so it is illogical to be using belt convey. So they use pneumatic conveying, where there is blower air here, and then the product enters from here. So up here there should be the separation, and then the product enters, and then it flows here until the next unit operation, which is the pelletization, and then so it is usually operated at elevated temperatures to prevent carbon black from mixing with liquid water. So since we have dried the carbon black, we don't want it to be mixed with liquid water again. So at elevated temperatures, the elevated temperatures causes the water to vaporize and it is in gas form, and usually the rate is 1520 meter per second, and it is separated from the pneumatic system by the means of cyclones. So in the end, here there is usually cyclones. So that is how the carbon black gets separated from the pneumatic system.
The next process is densification and pelletization. Densification is a method of controlling the bulk or full density of carbon black without altering its rubber reinforcing properties by wet micropulvering prior to mixing. The fluffy black separated from the pneumatic system still contains considerable amounts of air or gas, and it has very low bulk density. Therefore, it has to be further densified before it can be used commercially. Densification process starts from the loose black surge bin, where from the process flow diagram, the carbon black will entering the surge bin here, where the black is stirred slowly. Various densification processes are used in the manufacturing of carbon black pellets and include vacuum rollers, spin pelletizers, and stirred tanks. In this case, vacuum densification is applied as it is the most controlled form of densification of the powder black. The carbon black is passed over porous rollers, the inside of which under vacuum. To increase the efficiency, the carbon black is gently pressed against the vacuum roller by means of a second roller. The next process after densification is pelletization, where it is processed on achieving a higher densification process. By undergoes pelletization process, the transport volumes of the product are smaller and it will be more favorable free flow properties and reduce dusting. Two methods are used industrially for carbon black granulation, which are wet granulation in pelletizing machine, followed by drying, and dry granulation in a pelletizing drum. In this case, in our process, we use wet pelletization. Here, wet pelletization. In the wet pelletization process, the carbon black is mixed with water in special pin mixers in which the amount of carbon black and water has to be closely monitored. The shaft rotates at 300,700 rpm and the pelletization water is injected towards the mixer axis through nozzles situated at different locations along the pelletizer. So this is water injected in the pelletizer. The water-carbon black ratio used is approximately 1:1. So after leaving the pelletizer, the wet pellets have to be dried. The dryer outlet temperature of the carbon black is 150 degrees Celsius to 250 degrees Celsius. So this is the dryer. Its temperature will decrease slowly as the carbon should not be too hot for loading and delivery for the consumer.
So we're moving on the last part, which is market information for carbon black. And we should know that the most country that produce carbon black is India and China. And the price for carbon black is usually, for the global price, is $1,200, but it keep on increasing due to higher demand and low supply. And carbon black market is expected to reach and was estimated at 11.99 million pounds in 2014 and now estimated around 20.2 billion by 2023 with a computed annual growth rate, which is CAGR, of 5.6% from 2018 to 2023. So we can see that this is the things that higher demand, which is in industry. We can see that most demand is tires, and then goes to plastic and others. It increasing year per year. And that's all for our carbon black production presentation. Thank you.